Let's find the equation of the tangent line of y equals 2x squared minus 1 at x equals 2. Well, I'm going to start by graphing that function, just so I can have a visual idea of what's going on. I know I'm going to graph a parabola, so let's just see what it looks like. It's the graph of y equals x squared shifted down 1 unit and stretched vertically by a factor of 2. Well, if I imagine plugging in x equals 1, I'd get out 1. If I plug in minus 1, I'll get the same thing. Oh, let's just go on and plug 2 in to make sure I do this well. Let's see, 2 squared is 4, times 2, 8, minus 1 is 7. So I need to extend my graph just a little bit. 4, 5, 6, and 7. I know my parabola would be symmetric about the y-axis, so I get that point over there. All right, so I have a nice happy graph here. I'm looking for a tangent line right here at that point. Let's see, that's the point 2, 7. All right, so I got a point that's going to be on my tangent line. I need a slope. The slope of a tangent line is the limit as h approaches 0 of my function of f of a plus h minus f of a all over h. All right, well, let's see what that means here. F of a plus h, well, that means I need to plug a plus h in for my function, and a is equal to 2. All right, there's my f of a plus h minus f of a. Well, I know when I plug 2 into the function, I get out 7, because that's what I did. So now I need to simplify this expression and take that limit. Right now I'm dividing by 0, so I know I need to do some amount of arithmetic so that I'm not eventually dividing by 0. All right, so let's see. That's a minus 8 hanging out there on the end. I have a 2 times, and I just want to multiply that out. All right, now I can distribute that 2 through. Nice things are happening. I have an 8 plus an 8h plus a 2h squared and minus 8 all over h. And that's a really nice fact because it lets me cancel out that 8. I'm going to move over to my second board here just to finish this. So that would be equal to the limit as h approaches 0 of 8h plus 2h squared all over h. I can divide out an h. And now, that's a nice happy polynomial expression in h. I can just substitute that 0 in, and the limit is 8. All right, that's my instantaneous rate of change at x equals 2. It's also the slope of my tangent line. All right, I'm gonna move back to my first board here. Because ... I found out that was equal to 8. So I have a point on my line, 2, 7, and I know the slope of my tangent line is now 8. So now I need to find the equation of that tangent line. All right, board 3. A point and a slope. Let's use point slope to find the equation of my tangent line. All right, we can distribute. I can add 7 to everything. And there's the equation of my tangent line. Y equals 8x minus 9. The slope is my instantaneous rate of change. And I could imagine graphing that tangent line. Y-intercept's way down there. But I'll tell you what. Let's take a peek at this on a graphing calculator. There's some other functions in there from a previous example. And let's see, what was the equation of my tangent line? Y equals 8x minus 9. Y equals 8x minus 9. And then I want to type in the original function, 2x squared minus 1. And let's just start off looking at that on the typical viewing rectangle. Excuse me, zoom 6. Here's my tangent line and my graph. And if I thought about it, up here at 2, 7, that's where they touch. My tangent line looks like it's just hitting the graph. It looks like it has the same steepness of the graph right at that point. In fact, right there, it's a little hard to tell the function away from my tangent line. Oh, as we graph tangent lines throughout the next unit, we're going to see that they touch our functions at one point close to where we're talking about. They might cross our functions in other places too far away. But one of the points of our tangent lines is that they look like our functions really close to the point, that I could actually use them to approximate the function. But more on that later.